everybody, and welcome back to Simple Science. My name is Miss Leslie, and I'm the Youth Services Librarian for St. Charles Parish Library. Thank you so much for joining us right here on St. Charles Parish Library Connected, and I hope to see you all summer long. And today's experiment is the milk rainbow. So you should have a few of these things around your house. Hopefully you do. I have this little pie plate. It doesn't have to be a pie plate. You can do it on a regular plate. I have some milk and some food coloring and some dish soap. It can be any type of dish soap. Okay, this does work better with higher fat milk. So skim milk is not going to be as cool as if you have like 2% or whole milk. So, all right, so let's get going. So I'm going to go ahead and pour the milk into the pie plate. And you know what? Let's take a closer look.
All right, great. Now we have a really good view of what's going to happen. All right, so the milk is in the pie plate. And one of the things about milk and any other liquid is it has something called surface tension, which is the property of the liquid to hold all of the molecules together. So if something has a really high surface tension, then the molecules on the surface of the water are going to hold tight, 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 tight. And they're not going to move around too much. But if you have something that has a low surface tension, then the molecules are going to be able to move around the surface of the liquid. So let's see what happens. Let's use the food coloring to see if we can see what the surface tension looks like. So I'm going to put a few drops of blue. Okay. As you can see, it kind of just stayed in little drops all around. It's not going anywhere. So that tells me that the surface tension of the milk is kind of tight. It's got a high surface tension. Just for fun, let's add a few more colors. Some green. And some yellow. Couple of drops of red. Right. And as you can see, since the surface tension of the milk is still pretty tight, the food coloring's pretty much just sitting there. But there are things that we can add to liquids to change the surface tension of the surface. So I'm going to add just 1 or 2 little drops of the dish soap, and that is going to lower the surface tension, which makes it easier for the food coloring to move around. So let's see what happens. It doesn't take a whole lot. Wow. Let's put a little over here. Look at all those colors go. So now that the soap has lowered the surface tension in the milk and the molecules are able to move around, you can see how that has distributed the food coloring all around the milk. And as it swirls around, it'll interact with the soap will interact with the fat in the milk and continue swirling. So this will actually go on for a good few minutes. And if you have different types of milk at home, like if you have like half and half or evaporated milk, sometimes your parents might put in their coffee, then you could experiment to see how long your swirls go with different types of milk. We're going to watch this for a couple of good seconds. And while we're watching this, let me tell you that summer reading has begun. The sign up started on June 1st. So all you have to do is just read 360 minutes all throughout the course of the summer, log those minutes, and we are still giving out our fun prizes for just signing up and prizes for completion as well. Simple Science will be every week on Tuesday mornings. And we're also bringing our special guest tomorrow. Mr. Alex McConduit is going to be joining us Wednesday evening for some story times. And he's a wonderful local children's author. So take a look at our online calendar for more fun events that we're going to be bringing you all summer long. And also, don't forget about Programs to Go, where you get everything in a little bag to take home to do great fun activities like this and others all summer long. All right, see you next time. Bye.